Hello, and welcome back to Calero Academy. Today, we will be outlining how to find the area of this shaded triangle, which is bounded by some lines which are intersecting with a parabola. So, the setup of the problem is that this parabola is simply the y equals x squared, which is the basic parabola, and these two lines are parallel. And this line that goes through point C is tangent to the parabola, whereas this line goes through 2 points of the parabola. So, this Calero video is going to be very interesting because we are not going to do this problem in a very orthodox way. If you try to find the area of this triangle in the normal way, using half of base times height, it's going to be a nightmare because, look at point C, the only height that you'll be able to use is point C to some point over here, which will be D, call it. And you'll have to use AB. So what you're going to have to do is that you are going to have to find all the points in terms of one constant, or one or two constants. You are going to have to you're going to have to equate some equations of lines. You're going to have to use the distance formula, which is a nightmare. And at the end of it, it turns out that you're going to have to equate something like 36 to 49 terms. I forget which. In short, it is a nightmare. And thus, we are going to do this in a different way. And it's interesting because we are going to do away with our coordinate system. We are just going to refer to it a little bit only. So, how else can we find this little shaded triangle? So, what we can do is complete our triangle. We can draw a quadrilateral that contains our shaded triangle. Sorry about that, a little bit messy. And so, what do we do here? Well, let's plug in some values that we know. This side is going to be equal to what? And here, what is it? Well, to do that, we are going to have to find out what these points A, B, and C are. Now, normally if you were doing this problem, you would like to find all these points in terms of one or two constants. However, here we are going to change this all entirely. We are going to call A point A. We're going to give it the x-coordinate cap A is equal to little a, and therefore its y-coordinate will be a squared because it lies on the parabola y is equal to x squared. Point C, cap C, similarly will have x-coordinate C, and point cap B will also have x-coordinate B, and therefore their y-coordinates are c squared and b squared. So, what do we do now? Now, therefore, this side from here to here is going to be equal to the difference between the two heights of a squared and c squared. So it's going to be equal to a squared minus c squared. And next, if we imagine this, so look, we can also do this. Now, what is this side? Now that side is also going to be equal to a squared minus c squared, of course. And finally, what is this side? Now that side, let's mark everything down, C, B, and A. This side is going to be equal to b squared minus a squared, as you can clearly see from our little coordinate system over there. Bump the camera a bit, sorry. So b squared minus a squared is the length of this side. Now what do we do now? We've gotten that, so how does this help us? So, what we do is we find the area of this entire quadrilateral. We add up the rectangle and this right triangle, and we subtract from that these two triangles. And after you do that, how does this help us still? Well, once we've done that, we've got our shaded triangle. So we've got our quadrilateral, we subtract these, and we have the triangle that we want. But we can simplify things a little bit further. Okay, so you can notice that C is going to be equal to A plus B on 2. And we'll plug that in a moment. And also, you can clearly see that this is true by just taking the average of finding the slope of one of the lines in our graphs. You can see this from looking at the line AB. The slope will be equal to A plus B on 2, but that slope... Oh, no, wait, what am I saying? Sorry. So, the slope of this line is going to be equal to 2C. The slope of this line, which is parallel, is going to be equal to A plus B. Now, what is therefore C is going to be equal to A plus B on 2. And we'll be able to plug that in later. So now, what is our area? Well, I'll write the end product for you. The area is equal to 1/8 outside of, b cubed minus 3ab squared plus 3a squared b minus a cubed. And we have substituted c is equal to a plus b on 2 into our equation to get rid of all the c's. So, and now, another interesting little thing is, if we go back to our parabola over here, there's a very peculiar property that relates the area of our triangle to the area between this line AB, and the parabola. It turns out that the area of the region between the line AB and the parabola, so we're shading in also these areas, is going to be equal to 4/3 times the area of the right triangle, the area of our shaded triangle. And so and you can still find that out by just using a little bit of integral calculus. But if you can't do that, it's just interesting to note, and you'll find that out later. So, thank you for watching this Calero video. We hope you enjoyed it, and again, if you have any comments, if you wish to let us make a video or something, just put it down in the comment section and we'll look at it. So thank you again, and goodbye.